Okay, we need to speed up a bit because I want to go to the beach. So sketch, use a pencil. 2, 1, 2. We can add up. I know we can. Different. That means they are not the same. Hydrogen bonding interactions between ammonia and water. Ammonia, NH3. Water, H2O. You have to know these. These are simple chemicals that you need to know, formulas and structures. So, hydrogen bonding interactions. What are they? Hydrogen bonds are a type of intermolecular force. They are between atoms of compounds. They hold things together. They affect boiling points and melting points. They are always indicated with a dotted line or a dashed line, rather than a full line. Now, how would I start this one? I would draw an ammonia. I would include a nitrogen and a hydrogen. I would make sure that I've got my lone pair indicated as well. Hydrogen bonding does not happen between a hydrogen and another hydrogen. Absolutely not. It happens between a hydrogen and an oxygen. So if I'm struggling, what would I do next? I'd actually work a little bit backwards and I'd go, okay, so this must be between a hydrogen and an oxygen. It can't be between a hydrogen and a nitrogen in this example because it says between ammonia and water, and I've already got my ammonia here, so it has to be connected to a water. So it has to be connected to the more electronegative atom in the water, which is the oxygen. So then from there, once I've joined it to my oxygen, I'd put in my lone pairs of electrons, and then I'd add in my hydrogens to finish off my water. And then I'd add in my dipoles because sometimes they are compulsory for the marks and sometimes they're not. So delta minus, delta plus, delta plus, delta minus, delta plus, delta plus, delta plus. How do I know that? I know that because I know that nitrogen is electronegative. I know that oxygen is electronegative in comparison to the in comparison to the atoms that they are bonded to. So this would be one type of interaction between the ammonia and the water. So this example is taking the hydrogen from the ammonia and the oxygen from the water. So the second example of an interaction would have to be between the nitrogen of the ammonia and the hydrogen of a water. So we've done this one. Now we need to do this one. I'm going to do it at the same time. I'm going to do it on the same diagram. You could do two separate diagrams if you wanted to. So here I've said it has to be between the nitrogen of the ammonia and the hydrogen of the water. So let's take this hydrogen of water at the bottom. No, let's take the top one so I've got more room. And then I'd do a dotted line because that's a hydrogen bond. I'd need it to be joining the nitrogen of the ammonia, so I'd draw that next. I'd make sure to put my lone pair in because that's where the hydrogen is going to be attracted to, because that's the most negative part of the nitrogen. And then once I'm happy with that, I'd then add in all of my other hydrogens. Now, I wouldn't really worry too much about where the hydrogens are. I wouldn't worry about the bond angles and that such, just because this question's just about the interactions and we're trying to do 3D stuff 2D. It's hard. So there's my hydrogen bond. I've put in my lone pair, I've put in my nitrogen, double checked it's not the same interaction, it's a different interaction. And then I finish off by just remembering to add in again those dipoles. Dipole, dipole, dipole. And that gives me both of the marks for that question.